Guys, welcome back. Mr. Math here. This video, I'm going to go over 16 through 20 of the AMC 10A 2021 fall. These problems are pretty tough, so this video might be a little bit longer, but I'm going to try to go as fast as possible so the video is not too long. So yeah, anyway, let's get started. And again, if you have any other solutions that you want to tell me or comments on how I solved the problem and have a discussion, I'm be very interested in that. So let's get started. All right, so number 16. So we have the graph of f of x equals absolute value of floor of x minus absolute value of floor of 1 minus x is symmetric about which of the following. Note that floor of x is the greatest integer not exceeding x. So some people call it like the greatest integer function. I just call it I just say like ceiling and floor just because I think it's kind of easier to think about, right? Well, I think what we might want to do is sort of imagine what this will look like. In terms of like as a graph, how is this going to look? So what we might want to do is just sort of draw this out and think like, okay, so the floor of 0 is 0. The floor of 1 minus 0 is 1. 0 minus 1 is -1. So at 0, we would have -1, right? So 0, -1. What happens at 1? Floor of 1 minus floor of 0. Right, floor of 1 is 1 minus floor of 1 minus 1, that's 0. So 1 minus 0 is 1. So 1, we get 1. For 2, we would get 2 minus the floor of 1 minus 2, which is, so 1 minus 2 is -1. The floor of -1 is -1. Absolute value of -1 is 1. So 2 minus 1 is 1. So we get 2, 1. For 3, we're going to get absolute value of floor of 3, which is 3, minus absolute value of floor of 1 minus 3. 1 minus 3 is -2. The floor of -2 is -2. Absolute value is 2. 3 minus 2 is 1. So it's looking like for every positive integer, we're just going to keep getting 1, 1, 1, 1, 1, 1. What happens at -1? Well, the floor of -1 is -1. Absolute value would be 1. 1 minus -1 is 2. Floor of 2 is 2. Absolute value of 2 is 2. 1 minus 2 is -1. Right? And then, we can try that again from -2, right? And see, so we get the absolute value of the floor of -2 minus the absolute value of the floor of 1 minus -2, which is, so that's going to be -2, but that's going to become 2 minus 1 minus -2 is 3. Floor of 3 is 3. Absolute value of 3 is 3. 2 minus 3 is -1. So it's looking like for negative values, it's going to be -1. And for positive, well, negative values, non-positive values, it's going to be -1. And for positive values, it's going to equal 1. So if we think about that, that means that what point would it be symmetric about? Well, it's going to be symmetric about the point that's essentially halfway between those values, right? So it's going to be symmetric about the point 1/2 0, right? Because if you think about it, like this function, right, it's 1 up here and it's -1 down here, so the halfway would be 0. And the halfway between 0 and 1 is 1/2. So it's going to be 1/2, 0. Okay, so that one I think is really not that bad, as long as you understand those functions, right? Okay, and I'm trying to go a little faster just so that the video doesn't take way too long, but because some of them, some of the later ones might take me a little bit longer. Whoops. Oh, here we go. Okay, number 7. An architect is building a structure that will place vertical pillars at the vertices of a regular hexagon A, B, C, D, E, F. Right, so we have a regular hexagon. A, B, C, D, E, F, which is lying horizontally on the ground. The 6 pillars will hold up a flat solar panel that will not be parallel to the ground. The heights of the pillars at A, B, and C are 12, 9, and 10 meters respectively. What is the height in meters of the pillar at E? So I will say that, I solved this problem using vectors and using the idea of it involves some pretty complicated vector math, which hopefully you're familiar with. At my school we offer the course called IB Math Higher Level, and in that course we teach vectors and including three-dimensional vectors and the equations of planes. So that's what I use to solve the problem. I have looked and seen much, much, much simpler solutions, but I only want to give I don't want to steal other people's solutions, so I'm just going to show how I did it. But keep in mind that there are much easier ways to do this problem than how I'm doing it. But essentially, okay, so if the height, and again, I use sort of a coordinate geometry system. So what I did was I said, so let's say if we draw the height at A, right, and I called this point 0, 0, 12, right? So 12, so basically it's like, and what I did was I had, I basically made AB the direction of the x-axis. So this would be like the x-axis. The y-axis would be in the direction, the z-axis is going vertically up from the hexagon. So this hexagon's in a plane, and the z-axis is going straight up, right? And then the y-axis would be perpendicular to line AB, but still in that same plane. So that being a 90-degree axis. So this would be y, and this would be z. And I use that as sort of my coordinate system. So the height at A would be z. So I guess I can call it like maybe A prime, right? So I'll call the points that are above those points A prime, B prime, C prime, D prime, E prime, and F prime, right? So then what does that mean about point B? So we know point B is 9 meters up, right? Oh, and I basically gave the distance of each of these sides, I called it A, little a, because we don't know the distance. And actually later on, I'm just going to make A equal 1, and it's going to make the math really easy. We can make A whatever we want. So for now, I'm just going to leave it as A, and then we can sort of plug in a value later on. So that means that the height at B, or the point, I guess B prime, would be A 0, 9, right? Because it's A in the x-axis, 0 in the y-axis, 9 in the z-axis, right? And then point C, right, going up here. So to get point C, we have to do a little bit more algebra because we need to know how far over point C is. But keep in mind that like we know that this is a regular hexagon. So if I were to sort of extend this line here, remember, I know that this angle here is 120, which means this is 60, right? And then same thing here, this would have to be 60 and 60. So I know this is equilateral, right? So that means I know this distance would be AA, right? So but if I make it so that it's going to be 90, but actually, sorry. So what I actually want to do is I want to make the line perpendicular to the x-axis, right? So I want to, from point C, I want to draw a line that's perpendicular to the x-axis. So this is 90, right? And then again, this angle would still be 60. Whoops, sorry, it's a 60, right? Which means this angle down here would be 30, right? So I have a 30, 60, 90 right triangle with the hypotenuse being A. So that means that, based on a 30, 60, 90, you should know sort of that, like, if this distance is a, this distance would be a over 2, and this distance would be a root 3 over 2, right? So that means like this little piece here would be a over 2, right? So that distance there is a over 2, right? So then that means that the x coordinate for point C prime, or for point C, would be a plus a over 2, or 3a over 2, right? So I'm going to kind of draw like I'll kind of write it here. So that would be 3a over 2. Now for the y-axis, it would be a root 3 over 2, because again, this distance here is a root 3 over 2, right? So that's a root 3 over 2, and then the height would be 10, which they gave us in the problem, right? So that's going to be the point C. So now what I did was I wanted to find the equation of the plane that contains I wanted to find the equation of the plane that contains these 3 points. So what you can do is you can use vectors, right? So let's say I want to find the vector a prime, b prime, right? Remember, a prime, b prime, c prime are like the heights of the pillars at each of those given points. So vector a prime, b prime would be a 0, -3, right? And if you're wondering how I got that, the way that you can find a vector from 2 given points is by basically subtracting the x, y, and z values. So what I did is I did a minus 0, 0 minus 0, 9 minus 12. So you get a 0, -3, right? Now, I also want to find vector BC, B prime, C prime, right? And the way I can do that is by doing, and again, it's like the same thing. So 3a over 2 minus a would be a over 2, right? And then a root 3 over 2 minus 0 is a root 3 over 2. And 10 minus 9 is 1. So that would be vector b prime, c prime, a over 2, a root 3 over 2, 1, right? Now, in order to find the plane that contains those 3 points, that contains these 2 vectors, I need to find what's called the normal vector, right? The normal vector is a vector that's perpendicular to 2 given vectors, and therefore perpendicular to the plane that we're trying to find, right? The way I do that, the way that I get that is by using what's called a cross product. And again, if any of this is stuff that you haven't learned before, like, you could either like maybe try to find a video, typically like on looking up sort of with IB math, International Baccalaureate Math, or you could leave me a comment saying like, could you sort of explain some of this math that I'm doing, right? So essentially I'm finding what's called n, the normal vector, right? So by doing the cross product, so what you do is like and I, j, and k represent unit vectors in the directions of the x, y, and z axes, respectively, right? So I would do 0 times 1 minus -3 times a root 3 over 2. So that's going to give me 3a root 3 over 2 I. And then it alternates. So then it's going to be minus. And then for j, it's going to be a minus -3 times a over 2, or a plus 3a over 2. 2a over 2, 5a over 2. So 5a over 2j, and it's minus because it alternates in signs. And then for k, it would be a squared root 3 over 2 minus 0. So a squared root 3 over 2k. Whoops. All right, so that's going to be our unit. That's going to be our normal vector, right? Okay, so I'm going to erase to make some room. So yeah, so I got that. So let's kind of bring this over here just so we can remember this. So that's going to be our normal vector to the plane that we're trying to find, right? So I'm going to, whoops, actually, hold on. Okay. Sorry. Okay, so now I'm going to just erase to make some room, and then now we want to find this plane, right? The way we calculate a plane is by using the following formula. N dot R equals N dot A, right? N is the normal vector, which we just found. So that's 3A root 3 over 2, 5A over 2, A squared root 3 over 2, right? Dot R is just a unit vector, is just a vector in any given, it's essentially any vector that exists in the plane XYZ, right? Equals N, which again is 3A root 3 over 2, 5A over 2, A squared root 3 over 2, dot A, and A is some known point in the plane, which the easiest one to use would be 0, 0, 12, right? That would be the easiest one for us to use. So I'm going to make this smaller. Not too small, just enough that I can still see it. I'm gonna rewrite that. So that's 0, 0, 12, right? So now if I do this out, I get 3A root 3 over 2x plus 5A over 2y plus A squared, whoops, no. Plus A squared root 3 over 2z equals 0 plus 0 plus 12A squared root 3 over 2, or 6A squared root 3. Okay, and let's see. So now, can we cancel out some A's? Yes. So what I'm going to do is I'm going to multiply everything by 2 and divide everything by A. So that'll give me 3 root 3 plus 5, 3 root 3x plus 5y plus A root 3z equals 12A root 3, right? Now, if we want to find the height at point E, right? So E is over here. So we need to think about what would we be plugging in to calculate E. Well, let's think about it. In terms of X, well, the X is going to be 0 because AB is parallel to ED, which means that like A and E are essentially starting at the same place, sort of horizontally, right? So X will be 0. Y would be well, here, let's think about this. So let's see, if I draw this, right? And remember, we know that this angle is 60, 30, this is 90. We know this is A. So then this must be A root 3 over 2, right? Which means this whole distance is A root 3. So for X, we're going to put 0. For Y, we're going to put A root 3. And then we want to calculate Z, right? And now, so by doing that, this will cancel out, right? And then I'll get 5A root 3 plus A root 3Z equals 12A root 3, which if we just look at this, we can tell that Z has to be 7. I made my mistake. My mistake was that I forgot that this was supposed to be, the 5a over 2 was supposed to be negative because of the alternating thing with the cross product. So this is actually supposed to be minus 5a over 2. This was also supposed to be minus 5a over 2. So that made this a minus, which means we actually get 17. So the answer is 17, which is choice D. Yeah, so I think I just got a little mixed up because I didn't understand what my mistake was, but yeah, it was basically I just forgot to put a minus sign. So, but anyway, again, I know that there are probably much simpler ways to solve this. So, you know, if anyone can show me a different way to do it, I'd be very interested to see that. Okay. All right, let's look at number 18. A farmer's rectangular field is partitioned into 2x2 grid of 4 rectangular sections as shown below in the figure. In each section of the farmer will plant one crop: corn, wheat, soybeans, or potatoes. The farmer does not want to grow corn and wheat into any 2 sections that share a border, and the farmer does not want to grow soybeans and potatoes in any 2 sections that share a border. Given these restrictions, in how many ways can the farmer choose crops to plant in each of the 4 sections below? Okay, I actually found this one to be not as bad. You kind of just have to sort of count out different situations, different scenarios. Right. So basically, so what I did was so let's just keep in mind what cannot be together. So we cannot have corn next to wheat, right? And we cannot have soybeans next to potatoes. So those things cannot be next to each other, right? So let's start by saying that, you know, we can put any of 4 different things into that top left, right? You know, without loss of generality, we can put any of the 4 things into that, right? So now what I did from that point on was I considered different situations. So we're starting with the fact of having 4 choices for our first thing, right? Now let's consider the case in which we put the same thing into the one below it. So, and again, let's just say we put corn here, right? And we're gonna, you know, say, and again, this is without loss of generality, right? Let's say we also put corn here, right? So, right, so given that it was any of the 4 possibilities to put here, there's only one possibility to put in the second space, right? And this is if we're putting the same thing in the one below it, right? So this is the case where we're putting the same crop in the one below the top left one, right? Now that will give us how many choices for this? It can't be wheat. Right? It can't be wheat. Well, what if we put the same one also here? So what if this one's also the same, right? Well, that's going to be one possibility, right? In which case you have 3 possible choices for this, because it can either be corn, soybeans, or potatoes, right? So you'd have 3 choices for that 4th one, but we could have also not put the same one there, right? We could put either soybeans or potatoes here, right? So that gives us 2 choices. And given that we pick either soybeans or potatoes, well, if we put soybeans, let's say we put soybeans here, right? well, then this cannot be potatoes or wheat. So that only gives us two possible choices for each thing that we could have chosen, if that makes sense. So those are all the cases where this is the same as the one above it, right? So now let's look at situations where it's not the same, right? Because either it's the same or it's not, right? So we know that we're counting all possible cases. So let's say this is not the same. Well, it can't be wheat, so it has to either be soybeans or potatoes. So that's two possibilities, right? Now, let's say that let's just say again, without loss of generality, let's just say we put soybeans here, right? So again, looking here, this can either be the same as the one before it or different from the one before it, right? If it's the same, it's going to be soybeans. That's only one possible case, right? Now, what does that leave for what we can put here? We can't put wheat or potatoes. So that means we can only have two possible choices if we put soybeans there, right? What if instead we put corn there, right? So what if we decided to put corn there, which would be allowed? So in other words, we put the same crop here as here, right? Those are the same, right? Well, then how many? That's one case, right? Because it's the same as whatever was here. How many possibilities can be here? Well, this can be corn, soybeans, or potatoes. Just can't be wheat. So that's three possibilities, right? And then the other possibility is, what if we put the one thing that this cannot be next to, right? The one thing that can't be next to, which in this case is wheat, right? So what if we put wheat there? Well, if that's the case, then this cannot be corn or wheat, but it can be either soybeans or potatoes. So it's two possibilities if we do that. And you can convince yourself that that's all the possibilities because it's basing everything on whether the previous one is the same or not the same, right? Which is exhaustive. So there's no other possibilities. So if we calculate this out, this equals 7. So we have 4 times 7 plus 2 times 2 plus 2 plus 3, 7, right? So that's 4 times 3 times 7. 12 times 7 is 84. So there are 84 possible things with these given restrictions, right? Okay, and I keep saying this, but again, maybe you found a much better way to do it. I found this to be pretty systematic because it was entirely based on, am I, putting the same as the one before or a different one than before, and using those restrictions to count every possible case, right? So that way I know I've covered all possible situations. Okay. Number 19. Yes, I remember this one. Okay. I remember I kind of misinterpreted it at first, but it's not really that bad. So a disk of radius 1 rolls all the way around the inside of a square of side length greater than 4 and sweeps out an region of area A. Sweeps out a region of area A, right? A second disk of radius 1 rolls all the way around the outside of the same square and sweeps out a region of area 2A. The value of S can be written as A plus B pi over C, where A, B, and C are positive integers, B and C are relatively prime. What is A plus B plus C? Okay, so we have to imagine like what would happen if we took a circle, right, and kind of had it like, in here, and the circle has radius 1, right? And that circle is going to sort of roll around the inside of the square, right? What kind of shape is it going to make? Well, on the inside, it's basically going to make a sort of like another square, right? But if you think about it, it's also going to leave little rounded out corners, right? Yeah, so it's going to leave like little rounded out corners, right? Because, you know, it's a circle, so it's not going to reach the edge here, right? But on the inside, it's just going to sort of create a sort of a square, right? And the square will have a this will have a width of 2, right? Um, so if we think about it, um, well, if we kind of chop this up, right, we're gonna have a bunch of little things like this. Um, so it's gonna be what? So it's gonna be s minus 4, right? Because this distance would be s minus 4 times 2 times 4, because there's 4 of them, right? Plus, um, so if we kind of picture what this thing looks like, it's sort of something like this, right? Where it's like this is a quarter circle, and then this, so it's sort of like a 3/4 of a square. So it's like 3/4 of 2 squared. But remember, there's 4 of them, right? Plus 1/4 pi r squared, where the radius is 1. So just pi, basically, right? So you have like that, right? That's going to basically be that area, right? S minus 4 times 2 times 4. So it's 8s minus 4, right? Plus 4. So it's going to be 3 times 4 plus 2 pi. 8s minus 32 plus 12 plus 2 pi. 8s minus 20 plus 2 pi. Right? So that's sort of that inside area, right? Which we would say, which I guess what we call A, right? Now, if we look at the outside part, the outside part is going to look kind of, whoops, sorry. Let me do that better. The outside part will sort of look like, kind of like that. Like it's going to sort of create like rounded edges, but these are straight, right? Yeah, sorry. I know it's not great, but that's okay. So, and again, each of these has like a width of 2, right? And then this length is s. So you have 4 times 2 times s. So essentially 8s, right? Plus these, and now these are quarter circles, right? But they're quarter circles with a radius of 2, right? Because this distance is 2. So you have this quarter circle with a radius of 2. So obviously, if you add them together, you get a full circle with the radius of 2, pi 2 squared, 4 pi. So you get 8s plus 4 pi. Now remember, this area is double. So 8s plus 4 pi equals, whoops, 2 times 8s minus 20 plus 2 pi, right? So 8s plus 4 pi equals 16s minus 40 plus 4 pi. 4 pi's can cancel out. 8s equals 40. S equals 5. Make a mistake there. I apologize. I actually don't know how I made this mistake, but this over here should not be 2 pi. It should just be pi. I don't know where I made that mistake. Because it should have been, because essentially you had 4 quarter circles with the radius of pi, with an area of pi. So it should have just been pi, not 2 pi. So that means this is just pi, which means this is 2 pi. Which then if you solve that, this becomes 40 plus 2 pi. Which means that, so if you do this, you get S equals 5 plus 1 pi over 4, which if you add 5 plus 1 plus 4, you get 10. So the answer is A, 10. Again, I apologize for that mistake. I'm a little surprised I did that, but you know, we're all human, and I'm kind of looking at notes that are a little bit hard to read, so. Right, but sometimes mistakes are a good way to learn, so. All right, number 20. All right, so number 20, I actually didn't find as bad, I think. I thought it was like pretty reasonable. So it's essentially asking how many ordered pairs of positive integers, so what we usually call lattice points, exist where both x squared plus bx plus c equals 0 and x squared plus cx plus b equals 0 do not have distinct real solutions, right? So what I did was I used the quadratic, because essentially, you know, when you have x equals negative b plus or minus radical b squared minus 4ac all over 2a, right, this thing is called the discriminant, and if that value is less than 0, you don't have real solutions, and if it's equal to 0, you don't have distinct solutions. So we want those values to be less than or equal to 0. So if I look at this and I think about what's the discriminant, right? Negative b plus or minus square root b squared minus 4ac needs to be less than, so b squared minus 4c has to be less than or equal to 0, right? And then over here, it would be c squared minus 4ac, which is b, right? Because b and c are switched, so it's b squared minus 4ac, c squared minus 4ab. C squared minus 4b is less than or equal to 0, right? So I need those to both be true. So what I did was I sort of graphed, what I did was I sort of treated, what did I do? Well, it doesn't really matter which you pick. Like you can let b be x and c be y, right? You can, right, like treat them as being x and y, right? So maybe b is x and c is y, right? So I'm essentially graphing the function like, so I want to have like x squared minus 4y is less than or equal to 0, and y squared minus 4x is less than or equal to 0, right? So if I graph that, well, whoops, there should be a 4 there. Well, 4y equals x squared is y equals x squared over 4, which is going to make just sort of a wide parabola like this, right? And then x equals y, x is greater than or equal to x is greater than or equal to y squared over 4, right? Would basically be So here, I'm going to use a different color. Would be like this, right? It's like a side, it's like the inverse. Now, if I want, remember, it's y is greater than or equal to x squared over 4, which means I'd be shading up, right? I'd be shading sort of upward, right? And then x is greater than or equal to y squared over 4 means I'd be shading this way. So I'm looking in this shaded region here, right? I'm looking for lattice points that exist in this shaded region. So maybe first thing I want to do is figure out where the intersection point is. Well, clearly this intersection point is 0, 0, and this intersection point is 4, 4, which already tells us that 4, 4 is one solution, right? So then what I did was I tried to basically test out some different lattice points, right? So I tried out 1, 1, 1, 2, 1, 3, 1, 4, right? 2, 1, 2, 2, 2, 3, 2, 4. Well, and the thing is, 2, right, 2, 4, and then 3, 1, 3, 2, 3, 3, 3, 4, and 4, 1, 4, 2, 4, 3, 4, 4. And the good thing is they're actually pretty easy to check pretty quickly. And we can also tell that 1, 1, 2, 2, 3, 3, and 4, 4 must be there because they're clearly right in the middle, right? So there's at least 4 that work. And then what I did was I just tested out the rest. And instead of showing you all the math, I'll just sort of tell you which ones worked out. So 1, 2 works. 1, 3 does not. 1, 4 does not. 2, 1 works. 2, 3 doesn't. 2, 4 doesn't. And then that was it, basically it. None of the rest worked. So none of these worked. So the lattice points that work are 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. So that gives us 6 lattice points that work in that situation, right? So, all right, so now I've done 1 through 20. I don't intend to do the last 5 because I'm going to be honest with you, I kind of got some help with some of them, and I don't feel that it's fair for me to just present a solution that I didn't come up with myself. I might give a solution for one of the problems. I can't remember which one off the top of my head. It might be number, I'm having trouble remembering which one. I think it was 22. Yeah, I might give a solution for 22 because I kind of had my own solution for that one. 21 I got, but I made a mistake. I used stars and bars, but I forgot to take into account the likelihood of each event occurring as opposed to just how many ways that they could occur. So I initially got that one wrong. But I think by trial and error, I would have guessed E anyway, because my answer was 20, which is bigger. So I probably would have picked 16 by trial and error. And then 22, I did come up with a solution for that one. It's a little complicated, but I basically use similar triangles. So maybe I'll do a video of just 21 and 22, but I probably won't do a video for the last 3 because I didn't come up with my own solutions for those. So, okay. So anyway, I hope this was helpful in any way. Please, leave a comment discussing any solutions or your solutions or having a discussion about any of the problems, and that'll be it. See you soon.